Okay, let's unpack this. Imagine a place on Earth, just so quiet, so desolate. It seems like nothing could possibly stir its ancient silence. But deep beneath the frozen plains of Antarctica, a, a mysterious pulse has been detected, and it seems to be defying everything we thought we knew about physics.
It's a fascinating riddle, definitely. Our sources detail NASA's ANITA experiment. That's the Antarctic Impulsive Transient Antenna. Now, it was originally designed to listen for these ultra-high energy cosmic neutrinos, particles streaming in from space.
Right, from space.
But what it picked up instead was this powerful radio signal that seemed to be rising up from the Earth, not coming down from above.
Okay, so this baffling phenomenon, it's often called the Anita anomaly, right? And that's what we're diving into today. Our mission here is to explore what Anita actually was, the strange nature of this signal, why it has scientists scratching their heads so profoundly.
It really does.
And the incredible, sometimes, truly radical theories being proposed to try and explain it. It's a deep dive into the unknown right beneath our feet. And it could genuinely challenge fundamental science. So let's start with Anita itself. I mean, this wasn't just some backyard antenna, was it?
Oh, no, not at all.
We're talking NASA, a massive helium balloon floating, 35 kilometers above Antarctica. What was it actually trying to do way up there?
It was essentially a giant ear, you could say, finely tuned to detect the universe's most energetic whispers. Anita was searching for a very specific signature, these high-energy neutrinos coming from distant cosmic events.
Okay.
And the idea was when these sort of ghostly particles interact with the huge ice sheet below, they produce a subtle radio pulse.
Ah. Oh.
Anita was built specifically to detect those downward traveling signals, confirming these messengers from across the cosmos had arrived.
But then in 2006, and it happened again in 2014, it caught something completely unexpected.
That's right.
An upward traveling radio pulse. And this is where it gets truly mind-bending, isn't it? Because according to everything we understand about particle physics, this just is, it shouldn't happen.
Exactly. I mean, neutrinos are famous for being elusive, right? They're nearly massless particles. They can pass through planets, stars, even your own body with almost no interaction whatsoever.
The ghost particles.
Precisely. But Anita's signal indicated a tau neutrino behaving in a way scientists simply could not explain. What makes a tau neutrino particularly baffling here is that it's the heaviest of the three known neutrino types.
Heavier. So shouldn't it interact more?
That's the point. Heavier particles typically interact more strongly with matter, so its apparent unimpeded journey through thousands of kilometers of Earth is fundamentally contradictory to our current models.
So it's kind of like throwing a pebble at a brick wall, expecting it to pass straight through.
Right.
And still have the force to maybe dent the wall on the other side. It's just...
It doesn't compute with standard physics.
Yeah. This isn't just a minor puzzle, then. It suggests a fundamental gap in our understanding of how matter and energy interact at these extreme scales. It could potentially require a complete rewrite of physics textbook.
Really could.
And I suppose initially, back in 2006, some might have dismissed it, maybe an equipment error or some kind of reflection.
That was considered, of course, instrument effects, local interference.
Yeah.
They checked for all sorts of things.
But then in 2014, a second, even stronger signal emerged. And that one was impossible to ignore.
Yes, the striking similarity between the 2006 and 2014 signals was truly compelling. The angle they came from, their strength, and even their polarization.
Polarization, what's that mean in this context?
It refers to the specific orientation of the radio waves as they travel. For them to be nearly identical in both events, originating from the same, desolate region under the ice, it meant scientists couldn't just dismiss it as a random glitch or reflection anymore. Their models consistently failed to recreate these observations, and that immediately pushed them to consider much more, let's say, exotic explanations.
Okay, so if known physics can explain it, and it's clearly not just a simple glitch, what extraordinary possibilities are scientists now exploring? What kind of theories are even on the table for something this radical?
Well, the primary scientific explanations, they tend to revolve around entirely new paradigms, things we haven't confirmed exist yet. For example, some theories suggest the signal comes from something called sterile neutrinos.
Sterile neutrinos?
Yeah, a hypothetical type of neutrino that barely interacts with normal matter at all, much less even than the standard neutrinos we know, making them a possible candidate for maybe penetrating the Earth undetected.
Interesting. Okay, what else?
Another idea points to ultra-heavy dark matter particles. Now, if dark matter, which we know makes up about 27% of the universe.
Right, the stuff we can't see but know is there.
Exactly. If it exists in extremely dense forms, it could theoretically have such incredible momentum that it just blasts through regular matter, maybe generating a signal like this on the way out.
Wow, and these are particles we haven't even definitively detected yet, let alone understood their full properties.
So that's the challenge. We're deep into theoretical territory here.
But it's not just about subatomic particles, is it? Our sources also talk about the incredibly unique and largely unexplored environment beneath Antarctica itself.
Exactly, that's another angle. Radar imaging has revealed this landscape beneath the ice that's far more complex than we ever imagined. We're talking vast subglacial lakes, bigger than some countries, ancient mountain ranges buried for millions of years, and even possible huge meteorite impact zones.
Buried under kilometers of ice.
Right. So this raises the question. Could these mysterious radio signals somehow be tied to deep Earth phenomena we just don't know about yet? Unknown geological activity, maybe? Or perhaps remnants of ancient cosmic collisions buried under the ice for millennia, interacting in ways we don't understand.
It's just astonishing to think about how much we still don't know about our own planet's depths. And, okay, let's follow this thread. If it's not a hardware glitch, and it's not a known particle behaving normally, and it's not even a known geological process, then what?
Our sources touch on theories that really brush the edge of the unthinkable, don't they? Pushing scientific boundaries quite far.
Indeed. When you're faced with such a profound anomaly, one that seems to break the rules, the scope of speculation naturally expands dramatically.
Yeah.
We start talking about things like dark energy, that mysterious force accelerating the expansion of our universe. Could it somehow be causing some unknown interaction on an earthly scale? It seems unlikely, but
you have to consider it.
you have to consider everything when the standard model fails.
Yeah.
Or maybe quantum tunneling, where particles seemingly pass through barriers they shouldn't be able to. Usually that's a microscopic phenomenon. Seeing something like it potentially happening across thousands of kilometers of Earth, that would be truly mind-bending.
Yeah, absolutely.
There's also just this straightforward, if unsatisfying, idea of an entirely new form of matter, something completely undiscovered.
And then there are the even more provocative notions mentioned in some discussions. Our sources mention things like, well, advanced underground civilizations, or maybe signals escaping from old, abandoned military research stations down there. How do those kinds of ideas even enter the scientific conversation?
Right. Well, those are, of course, highly speculative ideas. Let's be clear. They aren't formally endorsed scientific theories in the same way as sterile neutrinos or dark matter. They tend to arise primarily from the sheer desperation, frankly, to find any explanation for a signal that so utterly defies known physics. When all conventional avenues seem exhausted, even the most imaginative possibilities might get floated, if only to be meticulously examined and most likely ruled out. The sheer magnitude of the anomaly itself encourages this kind of broad thinking, even if it ventures far, far beyond our current understanding or evidence.
Okay, that makes sense. These are truly paradigm-shifting possibilities, though. Even if unconfirmed, the fact that such radical ideas are even, whispered about speaks volumes about just how big this mystery is. So how are scientists actually trying to get concrete answers to this? What's the next practical step?
Well, to really pursue answers, NASA and the University of Hawaii have prepared a new mission. It's called PUEO.
PUO.
Yes, PUEO, the Payload for Ultra-High Energy Observation. It's designed specifically to launch in Antarctica, likely on a similar balloon setup. And its core mission is essentially to either validate or disprove Anita's mysterious readings, to see if it happens again, basically.
And PUEO is what, more advanced than Anita?
Yes, significantly. Equipped with more sensitive detectors, it has wider scanning angles to cover more sky and ice, and it incorporates more sophisticated, deep-layered data analysis techniques.
So this sounds like it really could be the key to unlocking this whole mystery, finally getting some definitive data.
It truly could be. It's a crucial next step. If PUEO finds the same upward-moving signal, maybe even more clearly, well, the mystery will only deepen. It would force a radical reevaluation of fundamental physics and potentially confirm a phenomenon that requires entirely new physical laws.
And if it doesn't find anything?
If it doesn't, then the Anita anomaly might remain an isolated, unexplained puzzle. Maybe some kind of systematic effect in the original instrument that we haven't figured out yet. So it's a pivotal experiment, really. One chance, maybe, to potentially rewrite our understanding of reality.
So wrapping this up then, what does this all mean? The Anita anomaly, these powerful upward-traveling radio signals from deep beneath Antarctica, they truly challenge the fundamental laws of reality as we currently understand them. We've explored how known physics suggests this just shouldn't happen, from the bizarre apparent journey of a heavy tau neutrino right through thousands of kilometers of Earth.
Which should be almost impossible.
Right, to the inability of scientists to actually recreate these unique signals in their models. And we've considered the proposed theories, from entirely new particles like sterile neutrinos or ultra-heavy dark matter to maybe unknown deep Earth phenomena under the ice. Or even those truly far-out notions involving dark energy, quantum tunneling on a massive scale, or entirely new forms of matter. The upcoming PUEO mission, as you said, is our next big hope to either validate this unprecedented observation or maybe finally put the mystery to rest.
And perhaps, if we connect this to the bigger picture, this raises an important question for you, the listener. The Anita anomaly serves as this powerful reminder that not all the answers, not all the big mysteries, lie above us out in the cosmos. Sometimes the most profound and challenging questions, the ones that could genuinely rewrite our scientific models, might be pulsing silently, waiting to be understood from deep below our own feet. It's, I think, a powerful reminder that there's always more to learn and that true fundamental discovery can emerge from the most unexpected places, even right here on our own planet.